And we're live, okay. Hello all, hello world. This is day 92 of studying compilers every day in Thailand, a compiler role. Yeah, I just got back from solar car pretty much. I'm pretty tired. I toasted like a slice of bread, so I'm set for now, but I'm quite tired. So hopefully today's stream doesn't give me too much trouble. Last time we added like printing for trees, so we can use that to vomit out debug info. And we also found out that our tree merging was broken. So we caught a bug with our tree generation, but I think all of that is sorted out now. The only thing that's left for us to debug until we finally figure out tree tiling is the tree merging stuff, and that is currently broken. So hopefully I can debug it today. Okay. So we have the build here. Yeah, so it vomits out everything, but it seg faults, which is very much not ideal. Yeah, so trying to figure out why it seg faults. I need to rebuild it real quick because I got rid of the print statements, so it should just seg fault now. Yeah, okay. And then with opt it doesn't seg fault, so that's an interesting outcome. Yeah, let's see what we can do. So let's run the debug stuff. Let's do that, and then show 0, test, regression input. Let's give it op. Oh right, this does not help us at all. Okay, we need to set a breakpoint somewhere. Where should I set it? I guess in merge trees, surely. This would be the most sensible place. Let's set it like here, I guess. I don't know. Yeah, breakpoint. Let's do that. So what happens if I just keep running? Okay, so it fails the second time at least. Maybe it'd be easier if we give it a different test. Maybe like a smaller test, I guess. We can just make test dots. Oh, that's not what I want to do. Yeah, let's give it like test.c. Let's make this up as we go. So I guess we could just do this. Do this, I plus 1 or something like that. Or even just like this, right? Or no, we can do I plus 1. Yeah, so let's maybe we throw it into Valgrind now? That might be easier. Okay, so this is enough to seg fault actually. So if this is just 1, even that seg faults. Interesting. Even with opt? That's really strange. Why is that what changes? Oh, what's good, Blueberries? Good to see ya. Thanks for tuning in today. Oh, maybe it's this branch that's causing something to break. Yeah, so maybe it's something to do with the allocates. Let's do this and return I maybe. That has more stuff in it actually. Let's not do that. Maybe this will work. What you're working on? So I've been doing this whole instruction selection stuff for a bit. Last time we added printing to the trees that we've been generating. So this time I'm using that to help debug stuff. This should not be as complex as it is. I guess this is, actually no, this is pretty reasonable. What happens if I just do this? So this just alone segfaults for some reason. That's what I'm trying to figure out. I suspect it might be this basic block gap. What's good, Niraj? Hopefully you're doing alright today. Okay, let's add the print statements back. I want to see what it's trying to do, at least. Or actually, we can make simplify CFG. Just work on Arduino project? Good stuff. It seems fun. Wait, that's what breaks here? Wait, the fuck? Okay, wait. So this simplify works. So the return is definitely causing an issue somewhere. Or at least something here is causing an issue. Let's finish a bunch of discrete homework. Ooh. What y'all covering in that class right now? Recurrence relations with generating functions. Good stuff. I don't think I remember that, I can't lie. It's been a little bit too long since I've taken discrete. Okay, well let's give this just a different pass. Let's give it mem to reg instead. And then, okay, that runs. So it's not the branch. It must be just when it's actually trying to merge something, it's breaking. But I'm not really sure why off the top of my head. Let's do that. Let's give it test.c. Okay. So one iteration. Okay, so. Oh, the splices. No, we don't. No, we make new iterators, so that should be fine. Okay, let's see. So size is 0 for merged trees. Wait, what the fuck? Oh, that makes sense. Can I do my project that I made? Yeah, if I have time at the end, I'll probably show it. I'm quite tired though, so I might call the stream short. Or I'll end up locking in really hard on this, in which case, my fault. Where am I? Okay, so what's it trying to merge here? let's just nuke this. What am I looking for again? Merge trees. Let's just set a breakpoint here. I think that would make sense. Or actually, let's set a break here. Okay. So we're here. This is the first run. So we're looking at, we're adding load putter, I think. Right? Oh wait, no, we're adding an assembly tree. So step over. Okay. So we're currently looking at this ret over here, I think. Right? Or yeah, we're looking at the ret. I don't know, I'm lost. Let's nuke it again. I'm looking for merge trees. So let's launch program. So we do that. Let's give it the, let's do the simplified version. Let's give it simplify CFG. Let's do that. So then we can work with this more directly. And there's less confounding factors. So the only, so it should just add for this, it should 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 add, wait, no, these are already added, right? Oh wait, I see, okay. We can definitely figure out what's happening a little bit easier here. Okay. So step over. This first one is an assembly tree. Yeah, so the first one's an assembly tree, so this should go over this, right? Yeah, okay. So we try merge. That should be uninteresting. So then we slice. Next run. Into, okay, sure. So we go to the breakpoint. Okay. And so now we should be looking at the return, or no, we just looked at the return instruction. We should be looking at the load now, I think. And then this should go inside this. Yeah, okay. So let's, next one, this should go to store. So so this is the instruction we're at right now. We should skip 1, 2, 3, 4. Yeah, four should be the interesting ones. 1, 2, 3, 4. And let's do one more. So this should be interesting. Okay, so let's, I guess we go into this now. So we can skip this, we want to step into this. Now this should be interesting. So this is where it should be breaking, I think. So let's get a list going. So we have reg3 equals load reg0. Okay, let's give this another shot. Let's just, you know what? Fuck it, let's use the text tool. Okay. Reg3 equals load putter 0, or just load reg0. Store reg2 into reg0 And these are in reverse order, so we can iterate through them easier. I'm gonna load reg1. We wanna store 1 into reg1. Reg1 equals allocate reg1, or yeah, allocate 8, I guess. Reg0 equals allocate 8. Okay. So how would the merges look for this? So we wouldn't be able to merge this into anything. This one we wouldn't be able to really. Oh no, we could merge this load in, I think. That would be safe. Yeah, okay. And then this store would not be safe, and nothing else we can really merge into anything. Yeah, so we would expect one merge here. So most of this would be the same. So reg3 equals load reg0, store reg2 into, or we want store load reg1 into reg0. Yeah, and then, right? Yeah, and then we want to store 1 into reg1. Reg1 equals allocate 8. Reg0 equals allocate. This should be a pretty reasonable example to start with, I think. This instruction looks a little bit stupid, but I promise, I promise it's not that bad. Yeah, this should be the final state of the merge, I think. We're not really doing any like insane arithmetic, so yeah. So how would we iterate through this? We should try one merge here, I think. Yeah, okay. So this is the first cycle. So I'm gonna step into this. Okay, so T1 iter. So this is a for each loop, I guess, sort of. So we're starting. We should be starting here. Let's get the pen out. We should be like here right now. There we go. All right, let's actually do this on a new layer. Okay, we're gonna maximize my artistic prowess here. Let's take this. Let's move everything over. Okay, huzzah. Okay. So right now we are here. I'm gonna draw a better arrow. There we go, first try. Okay, now I can like drag this layer around. Huzzah, okay. So that's the instruction we're at. I can probably close out of this. We can split screen this even, honestly. Okay. Probably make this a little smaller. Yeah, okay, cool. That'll do. Okay, so right now we're there. Let's also add a blue putter. It's for like tree 2, I guess. So let's make this clear. T1. This one will be all of its leaves. So the only leaf here is 3, I think. Or the only leaf is the reg0. Where am I? Yeah, let's just keep stepping, I guess. So we step into this. So we set T1 here. And we iterate through leaves. So the only leaf here is reg0. So this is the use. Yeah, so we're looking at reg 0 right now. This is not the last use, so we should just break there. Because the last use is here, I think, right? Or wait, no. No, this is the last use. Yeah, so we should go through here. But then we should hit this store, and that should cause us to quit. I'm fairly sure. Yeah. That should be what happens here. So let's step into this. Yeah. Step in. Oh. Okay. So we're gonna like step into. Hello. Get me out of here. Okay, here we are. First try. The uses. Yeah. This and okay, so we go through that, and then okay. The first one we look at is here, I think. Okay, so that's a thing. That's fine. Let's skip through those. Okay, so the blue arrow is cur. We should hit maybe alias's memory, I think. Right? I think that's what should break here. Yeah, I think that is what should break here. Oh, wait, what? Are we gonna... Oh, this is throw. Okay, so that... We hit the point where we're breaking. Okay. So, merge trees. So we're breaking in one of these two. That's really strange. Let's file grind this to get a better idea of what's happening. Or not mem to reg. We want simplify CFG. All right. So we're in get name. Wait, what? That's where it's breaking? Wait, what? That's crazy. Okay. Has memory instruction. Oh, wait a second. Wait, I think I know what's going wrong here. Yeah, so it shouldn't... Yeah, so we don't have a false case here. That's the problem, I think. Has memory instruction. Huh. Huh. What the hell? Oh, is get useless breaking? What if we just make this a bracket operator instead? Yeah, that might actually be safer in this instance. Let's try that. Oh yeah, of course there's no leaves. Wait. This is breaking worse than it was before. Valgrind is quitting on me. The fuck? That's really strange. Let's run it without while going. Is this just an infinite loop? Oh, I see it is. Okay. Okay, so the problem is definitely in here then, right? Oh, wait a second. Okay, wait, I think I know what's going wrong now. My logic is wrong here. So this is the for loop. So the while loop that we care about is this big while loop that I'm looking at. So while not seen. We're not really doing this correctly. We gotta check out each step. And then we wanna, yeah, okay, I'm kind of breaking here. Yeah, so I'm just checking once and then trying to merge, which is not gonna work because we can't really merge at this point yet. Yeah, so if any of these are true, then we should break, I think. Or actually, wait, what am I doing? Wait, I never used T2 scene. What am I, wait, I actually just completely bought it out here, I think. I think that's what happened here. So, we have this while loop. This is supposed to go until scene. Yeah, okay. So, if any of these are true, then instead of continue, we want to break. And then all of this stuff we want to put in it if T2 scene. Yeah, that's what we want to do. There we go. That seems more correct at a glance. Yeah, because if we actually, so if we, yeah, okay. So then if T2 scene, if we find it, then we will break out of this. Oh, but this needs to be after, I think. None of these consume cur tree, right? Yeah, okay. So then, yeah, so let's put this at the end of this pile. Yeah, so let's put this here. This brace is in the wrong place, I think. Oh no. Okay, I'm gonna need to do a lot of rewriting here, I think. So this while loop is the yellow brace, that's good. So after that, we escape to that. That looks fine. We just need to fix a couple of things. Okay, so we need to pull out the cur reg somehow, I think. Or we could just use T2 iter, actually. Yeah, so we can kind of just pull this out temporarily, and that solves the bug. Let's try rebuilding and then running again. It makes sense why my logic is broken, at least. Oh, wait, that's good. So let's do without. Okay, that might actually have been it. I think that was the only bug we had somehow. Yeah, that's pretty good. There's only logic bugs now, which is very helpful. All right, I haven't read chat in a second. Let me work down from this. So excited for the Thanksgiving break. Need some time off. Yeah, I kind of feel that. It's been a lot. It's been quite some time so far. Quite a quarter or semester. Learning some C++ and went down the embedded path, and you literally use 3 to 5 STL data types. Yeah, that makes sense. C++ is supposed to be a very general purpose language, so I think it's I think that's pretty fair. Although honestly, if you're writing embedded, you'll probably just use C instead anyway, so like it's kind of a moot point. Yeah. I only understand this stuff in an abstract way. I mean, if you want me to explain anything, I can do my best. It's just I don't really know like what to explain unless you like ask specifically. So yeah, don't worry about like asking questions. It helps me understand it as well, so it's pretty important in that sense. If it's like following an address, go GDB with... Oh. Yeah, I guess I could do that. Yeah, I should probably like... I definitely need more practice using a debugger. I don't really understand what your solution is doing, but that seems pretty reasonable. I think just like running it through Valgrind and just reading the stack trace is fine. I also, actually, does the debugger give me a stack trace even? Let's see. It should give me a stack trace. I don't know, anyway. What resources are you using or have been, I read that completely wrong. What resources are you using or / have you used? First try. So previously, I took a compilers class at my school, so I've kind of like, I used those slides pretty extensively for like a lot of my background knowledge, and I went back to one of those slide decks for one of these, I guess for instruction selection actually. Aside from that, in terms of books, the main ones I've been referencing are Advanced Compiler Design and Implementation by Muchnick, and SSA-based compiler design, I think it was called, edited by Rastello. Aside from that, there's also, I've like looked a little bit at the Cooper book, but I didn't really find it that helpful, at least for what I was trying to do. So, yeah. That's kind of the big pile. There's also a couple papers here and there for like very specific algorithms that I've been interested in learning, but yeah, that's kind of the holistic pile, I guess. I've been watching these VODs on and off for a bit. How inspiring work. Thank you. I appreciate it. Okay. Let me troll someone real quick. Alright, so I guess we should probably verify. The next thing we should do is we should actually verify that the output is correct. So we did the experimentation, or like we stepped through this by hand here at least. Yeah, we can get rid of these layers now. So what should have been merged is just these, I'm fairly sure, in this example. Yeah, so let's go to MIR to LIR. First time here, welcome. I'm making a compiler from C to x86-64. The goal, or I guess like, that is like the, I guess like the level 0 goal, just like the end product I'm trying to make. I guess like a level up from that is like pedagogically speaking, I want to get more experience with the algorithms that go into modern compiler design and sort of understand, I guess, why the design choices they made are the way they are. That was not an English sentence, but you get what I mean. So I'm like focusing a lot on the algorithms and just like a combination of the algorithms and writing code that is maintainable, I guess. Yeah, And specifically, I haven't done a lot of work with like the optimizer, because compilers also do a lot of code optimization. So that is, I guess, something that I plan on spending a lot of time on. I've already written a couple of optimizations, but there's a lot more that I can do. And yeah, it's gonna be a good time. But right now I'm trying to get this stuff to actually generate code. So I'm unfortunately in the back end for that reason, but it's also really cool and very scary and very easy to get lost. Okay, let's print real quick. Actually, can I just undo stuff here? Yeah, we can just do that. Let's throw this here. Before. And then, oh boy. What is program trees? This is, okay. So we want this, and then for auto tree and program. Oh, what am I doing? Actually, we can just steal this, and then we can do TMV, or we want FN trees to string. This should take OM. Let's print this. Oh boy, I can't type today. Great, wonderful. We have an extra semicolon for some reason. That's awesome, thank you. When did you first learn C++? I learned roughly like... I technically learned like 3 years ago, roughly, I think. I only like started using it in a serious capacity like a couple months ago though, so. Okay, so we have this. And then after merging, we should print again. Oh, this is a little bit more annoying actually, because the result is a list of shared footer of node. So this should be after, I guess we do. Let's make this prettier. Okay, so we can do that. Let's actually just, this is fine. We can just clean this up later. Has everyone been wording? Of course, yeah. It's been a lot of fun. Just getting to chat with people is also just been really cool. It turns out people online are a bit of a mixed bag. There's some people that are always very supportive. There's some people that are never supportive. It's all pretty funny though. I think overall I've had a pretty good time. And also like I think like the biggest value has just been like being able to I guess like force myself to consistently work on a project. That's been pretty regular, yeah. Blueberries has been a pretty consistent viewer. He's the GOAT. We all love him. What am I doing here? Merge trees, lots of list. This is shared footer to node. Okay. So we want to make a visitor real quick. So we want our tree, print node visitor, PNV, and give it operand manager. Okay, so instead of this, we want PNV visit. Actually, no. What am I doing? Let's put this in braces. Let's put this up here. do get results. Not node get, or arrow accept actually. This is less verbose. You can give it PNV. Okay, there we go. First try. That should, so this should print before and after now, hopefully. Alright, it builds, that's a good sign. And, okay. Is this in, okay, so the first thing I notice is this is kind of in, so there's two things I notice. First one is we're missing our assembly nodes. Second is, the output's backwards, because I forgot to re-reverse it. That's not ideal. Okay, what else is there? It looks like we just ate up something, I think. Or no, we just didn't merge. That looks like. Do you learn about SSA assignment in class? No, actually. That was completely on my own. One of the other classes we have here is supposed to teach it, but that prof has been a little bit missing in action as of recent, so I don't think I'll get a chance to learn about it in a formal capacity, but yeah, it is what it is. Okay, so something is wrong here. There are two things that are wrong. We're missing the assembly nodes, and this is backwards. So, what do we do about this one? Okay, I think, so let's fix the assembly one. Let's fix the assembly issue first. You never took the compilers course? No. So we have two compilers classes. One of them focuses on the front end and the back end. One of them focuses exclusively on the middle end. I took the one that focuses on the front end and the back end, which is why I have like some direction on what to do here, but I didn't take the middle end one, which is why SSA construction took like 3 weeks to do. So yeah, that's kind of how my life has been. What am I missing? Oh, I see. So we have that. We also need to paste this in here, I think. If there's a way we can like reverse this, actually, that would be great. We only have one grad compiler class? Yeah, that's fair. We have like 3 compiler classes total, and they're all like technically undergrad, I think. Yeah, audit seems like a good plan. I actually didn't know that was an option for the longest time, so that seems pretty strategic at least. Okay, so we should actually just push this back regardless, I think. Right? No, we shouldn't. We shouldn't do that. Yeah, because we need to do this push front stuff. This should also be a push front, I think, to be honest. Right? Right, no, this is push back. Yeah, so we push back that. Wait a second. Yeah, we push back? Sounds... Tree is the current tree. And we're iterating through it in reverse order, so pushback is correct here. Pushback here is also correct for a completely different reason, I think. Yes. Yes, okay. Yeah, this seems about right. So this should solve one problem. Yeah, what is ANN? I imagine it's something very mathy. I don't really know more about it. Do you aim to contribute to GCC, Clang, LVM, etc.? Yes. That's on my to-do list. I have an LVM issue assigned to me. I just low-key have been putting it off for the longest time. I should probably do something about that. That might be like a winter quarter deal for me. Yeah, it might be a while. Yeah, honestly, I think a lot of compiler classes are not really worth taking. I think the way they usually are structured is like half to 2/3 of the class ends up just being about like parsers, and then like none of that matters anymore because of like parser generators. And then you like very quickly go through the middle end, and then like at that point like you're already out of time for the back end, so like you cover it across like one week, and then like you don't really learn anything. And then like on the last day you get told that like Bison exists, and then like it turns out you spent like 6 weeks learning the least useful part of a compiler, and it's like, bruh. What about the design aspects? I don't think most courses cover it, actually. I think that's kind of something that like I lucked out on. But that's more like software engineering principles wise. So like things like the visitor pattern, or like using singleton registers, or just like making things more efficient broadly. Let's go 360 sauce. I'm streaming late today because I had a solar car meeting. So yeah, I'm on our solar car team. We're writing some Rust code. It's a little bit of a mess, but it always is, I guess. Okay, so this is not merging for some reason. This should be merging, I think. I'm not sure why it's not merging. You know if you're doing front end, middle end, or back end? Probably a combination of middle end and back end. I'm probably gonna do mostly middle end stuff. It'll probably just be writing like custom passes for GCC. So I'd have to like figure out what to do with that, but hopefully I can figure it out. It would be very nice if I could like not get fired. Yeah. So how do we reverse this list properly? Middle end's where it's at? Yeah, I think that's like the biggest place where quant does stuff. Not that they don't do things in other places, it's just like that's the most frequent case, at least. So how do we iterate through this, at least? I might just have to reverse the linked list and just eat the linear runtime. Or just like the fixed overhead. I guess like, it's kind of already doomed anyway. Like, everything else, the linear runtime is definitely not the largest component. I don't think it's the end of the world if I just reverse the list. Yeah, I'm just gonna reverse the list and call it a day. So let's go here. Hardware specs, yeah. It seems difficult. It seems very technical. I don't feel qualified for that. Yeah, and like front end's like kind of dry. Although I guess like Clang IR is pretty interesting to look at. We want merge trees, reverse. Okay. So now this should print in the correct order, and hopefully we have something merged. That'd be very nice. Nothing is merged. That's okay, fair enough. Let's give it a simpler program. Let's look at test C. Or let's give it something else that's a little more interesting. So let's give it like int I equals. Let's give it some function parameters. Let's do b minus 3, return I plus I times j. Maybe we could do something interesting here. Oh, I didn't need to rebuild. Whoops. Oh, that's seg faults. Wait, that's interesting. Why does that seg fault? Okay, so seg faults during the thing. Let's get rid of passes. Or let's give it mem to reg only. So let's look at the HIR output real quick. Or MIR. Oh, wait, it's 2 dashes. Okay, we have actual things to do here. Okay, so we can do that. Let's not dump MIR, let's see if this works. It's seg faults, that's not ideal. Why are there so many ASM? Oh, I know why. Let's do that. Or let's do that. Okay. So that eats up that, but okay, so these should be able to merge, I think. Yeah, these should be able to merge. Are you on the solar car team? How's it working with engineers? Honestly, I don't really get to work much with them. That's more of like a project level thing. I mostly just like, the way I understand it is the mechanical team is like the team that's like doing the actual work. And then the electrical team is like the glue for mechanical, and then software is like the glue for electrical. So in that sense, I am kind of just serving as the glue for the glue. So yeah, it's kind of just like writing code in isolation, which is kind of fun in its own way. It's just like interesting solving different problems, I think. For years, compilers were in the back of my head until I figured it could actually be interesting. Yeah, it's one of those things that like I think a lot of people don't really think a lot about. Like compilers as a whole is just like a lot of people just take them for granted, and it's really interesting to think about at least. Because like there's just so much that happens, and it's like it's crazy. Okay, so what is seg faulting? Okay, let's let's just add a print here. We're actually like merging. Let's include IO stream. Let's rebuild it. Let's see what's happening here. Okay, we're not even getting to that point. Let's run Valgrind. Take care, Doorbell. Thanks for showing up and have a good one. Okay, what is breaking here? Invalid read. Okay, so this was the issue we were running into before, right? With like the actual substantive test. Get name? Wait, what? That's where, wait. Is this by merge trees 135? This is here. Wait, that's where it's breaking? There's no way. Why is that what breaks? What the fuck? So the leaf is gone. Why is the leaf gone? Oh, wait. No, that returns... same reg. Wait, what? Wait, what am I doing here? This is where reflection would be useful for debugging, actually. Because now I can figure out the type of this. Okay. Let's... Alright, well, let's look at the output. How should this be merging? Let's do this anew. Let's make a new canvas. Let's do a little bit of tapping away. So we have... let's dump mir. Okay, so we have reg 4. Oh, let's make this a normal color. Small, reg 2, reg 3. Reg 3 is sub, reg 1, reg 3, or just 3. Reg 2 equals add, reg 0, and 1. So how should this merge? We should get... we should try to merge 3 upwards first. And then... oh wait, what am I doing? Whoops, that shouldn't be an R. Let's let's use a little bit of whiteout. This should be a %. There we go. That looks uniform. Yeah, that doesn't look pasted in at all. Okay, so it should try to merge 3 in, and then it should try to merge 2 in, and then that should be it, I think. This seems like it should be a pretty straightforward merge, but something is wrong, obviously. Looking at the print output, this seems fine. Or this print output's not the issue, at least. Oh, I know the problem now. Yeah, so the problem here is the leaf. I've made this assumption here that the leaf has to be a register. If we look here, we have 2 instances of leaves that are not registers, and they're numbers. I forgot that is something that can be done. So we need to accommodate for that, at least. Yeah, so let's do that. Let's fix that a little bit. We need to account for that everywhere here as well. Let's start down here. I think this is like the safest place to begin. Man, how didn't I think about that? That's a little bit brain damaged of me. Reg node. Let's do reg node. Yeah, this dynamic cast stuff will always just have to exist, I guess. So we want leaf get, or dynamic cast into register node. Maybe we just keep a 2-string visitor and then we 2-string the leaves. That might be smart. I might do that. That seems smart. I will do that. So we want 2-string or print node. That's actually, we should rename this anyway. So this should take OM. Where's OM? What the, we don't have, okay, I need to fix that. I'm gonna head to the bathroom real quick though. Don't burn down the house while I'm away. Yeah, should be a moment. Okay, I'm back. Good to see my place is still intact and not burnt down. Yeah, that's great. Okay, so let's keep this pile going. I need to figure out how to add the operand manager here to, I guess, print things. The insane way to do this would just be to give it a null putter, I think. Would that actually work? Null putter. Okay, that definitely doesn't work. Ah, I gotcha, I gotcha. Okay. So if trees, we should probably pass in operand manager then. Do I even need? Is there a reason I should do this other than just like two-string it, I guess? Yeah, this is better than a dynamic cast tree. I will do this. So we can pass it in by ref. We don't need that still. Okay, so let's go here real quick. Let's give it operand manager. Okay, so this is a ref to OM. Okay, so we can do that now. And then OM is fine here. So we can give it, so it's actually just, so we want leaf, accept, PNV, or ref to it. There we go. Let's actually just, yeah, let's do that. Let's rename this to TSV for two-string visitor. This will be important in a second. Yeah, okay, there we go. So we can do that. This is fine. We need to update it in Node real quick, I think. This is good, and this renamed it, I think, right? Yeah, two-string visitor. So that's good now. Yeah, I think that's it. Actually, can we just, yeah, that was a rename as well. What's wrong here? Oh, we need to give it OM now. Okay. So we want, oh, there's a lot here. So it's, is there a better way to look in backend specifically here? It's all front end. There we go. So those are the instances we need to change real quick. This should be TSV. That one's good. Yeah. This is the only other file. It should be TSV. Okay, there we go. All better. Okay, so let's keep going on this. So we needed that for a reason. So we want this here, so we can use the string representation, because that's kind of the best way to serialize it, I think. Or maybe not, actually, now that I think about it. We want a non-recursive version of it, I think. Yeah, we want a non-recursive version. Because this will... yeah, this will not work. So we went through all that effort for nothing, actually. But that's fine. So this should be node to string. So let's... Actually, no, it's just, So what are we adding uses to? I guess register string is fine. We shouldn't be adding uses of like literals anyway, so I think this is fine. Yeah, so we want leaf, and then so we want reg putter equals to, or we want dynamic cast to reg node or register node star. So we take leaf get. So if this exists, then we do that. And then we can actually just give it, I think we can just give it leaf, right? Or, no, we should just take register node, because we're already dynamic casting anyway. Yeah, so we can do that. That's nice. But if we're just doing one function, do we even need that? We can just do in the reg putter get name. We can just do that. Yeah, we can. Yeah, that solves all of our problems somehow. Okay, so we can push front the tree, which is good. Okay, so that makes sense. Get rid of that even to denest a little bit. Then we push back the tree and we continue. We continue with our day. Okay. Next up. I think, so this is fine. We want to clean up merge, or we want to clean up try merge now. Yeah, the rest of this seems fine. Yeah, okay, we can do that. Okay, so now we need to clean up this abomination of a function. I'd like to also at the same time make it suck a little bit less. It seems messy, so I'd rather avoid it. I don't think we need this anymore, ironically. Yeah, if there's a way we could like separate this out. Yeah, I think ironically we might just have to, we could definitely denest this actually. Yes, we can do that. Or wait, no. Let's C++ break out of outer loop. We might have to, this really sucks. I might have to use a goto here. Okay, well shit, okay. Yeah, let's use a goto. I can't believe I'm using a goto in 2025. What is this world? Okay, let's keep it as break for now, just for simplicity. Get rid of that as well. We want so if this and that, then we want to break. this would make sense. What time is it for you? It is currently like 10:45-ish. This is like a normal time. All right. So register string doesn't exist anymore, but this is fine. So we want. So this is a node star. So we want to do a quick dynamic cast. Haven't slept in 4 days. I mean, okay, you know what? Fair enough. That might just be the. I feel a little bit called out as a college student, but it is what it is. That's so funny. Okay, so we do this. So that we want to just continue, I think. Or actually no, that level we want to continue. So I want to do that. Actually, let's make this. So I want to do that, or yeah. There we go. That seems reasonable. Actually, no. We should keep it like this for now. Okay. This seems reasonable. And then so this should be. Let's actually simplify this if at all possible. Maybe we could just, yeah, we could avoid passing around shared putters as much as possible, I think. So we want T2 putter, or shared, I guess. Maybe I should use weak pointers actually here. Why do I even use shared putters? Like, I thought I needed it for merging, but we kind of use like a different data structure anyway now. So like it's a little bit unnecessary now, I think. Yeah, like we pass around node star anyway. So like, what is the point, right? Yeah, leaves should be like, is leaves even a shared putter? No, they should be unique pointers, I think, honestly. These actually should just be unique pointers. Right? I don't know. I'll resolve that later. For now I want this to just work. Okay. So we have this. So this is the merging pile. We can clean that up in a second. Let's make sure all this is fine. Creating compiler from scratch? Yes, pretty much. There's like, I'm using a parser generator, but that's about it. Actually, let's. Okay, we're gonna keep it as this, I think. So we can steal this. Shoot 2. This should take 2 get. So no T2 reg. We're gonna continue. So we want T2 reg, and we want to get string, or get name, I guess, rather. That seems fine. So then you make that. This is fine. That seems fine. This instruction's ugly, but it's fine technically. We should get rid of same reg, I think. What is consume? Do I even call that? No, I don't even call this. I don't even need that. So we want like we can okay, so each leaf this should have a curly brace there. Okay, so where do I even put this go to? So how would I do this? So if someone wants to create a mobile app, so you're a mobile app developer, but you want to create a project like a database. I think there's a lot of books. I think that is probably the best place to start. Yeah, you kind of just have to like do a lot of the reading, understand a lot of the, I guess, theory, and then you can kind of give it your best shot. Yeah. Okay, let's do that. I think this is fine. Wait, no, this will break out of the wrong loop. Did the forest make it through? It's still there, yeah. I'm keeping forest for the time being. I'll definitely rename it eventually, but it's just too good to not keep for now. All right, we're gonna use a go-to here. Let's do cannot merge. All right, we're doing some heinous shit right now. Yeah, the labels really break the formatter as well. That's the other tragic part. This is so dumb. I might have to update claim format. Labels. Okay, so this is a thing. So let's go to... Oh boy, what am I doing? So this should be true. So what if I go here and then false this? Okay, so that does that. What if I make this 8? Oh god, no. That's also not what I want to do. I'm not sure why that breaks it so much. Yeah, it should be double indented. Hey. Enforcer go-tos to be the same as defines and if-defs. That makes sense, yeah. I need to figure out Cling format to do things properly. Yeah, okay. So this looks like it's kind of just doomed for labels at least. Okay, you know what? Let's just avoid this issue altogether. Let's just deal with the go-to label. This is so stupid. What am I doing here? Let's just do that. This is very interesting code. This might actually be the one instance where go-to makes sense, by the way. If anyone is unfamiliar. Actually, this one we can just do a break, I think. Yeah, but these ones we need to go to, I think. Yeah, that makes sense. Alright, so broken as well? I see. That makes sense. I guess Cling format just wants to discourage it anyway, so like I guess it makes sense that they're kind of ugly. Okay, so what do we want to break out? We want to... Is it the for loop that we want to break out of? Yes, we want to break out of the for loop. Oh, wait, no. We want to break out of the while loop, not the for loop. Yeah, so we want to go here. Yeah, so this is correct, I think. I don't know, is it cleaner to use a go-to here than a break? Just for consistency anyway. I think that would make sense, even if it's like technically sloppy code. Okay, so we can do this. And then for curly, if so we want to get rid of the same reg. So what are we doing here? I think these should only fire if cur is an instruction, or cur tree is an instruction. Or not instruction. Wait. What is cur leaf? Okay, we need to do a little bit more dynamic casting, I fear. If you gotta use go-to, almost gotta commit to it. Yeah, that makes sense. It just seems a little bit... It seems a little bit strange not committing to it, at least. I suppose I kind of just have to eat it. Also, this T2 get stuff is starting to annoy me. So let's fix that up, actually. So we want T2 shared here. Auto T2 equals to shared get. This should be to, yeah, like that. So this is good, this is good. This is fine. Okay, so this might be the most ugly code I've written in a while. Yeah, this is fine though, right? Yeah, that works, right? This should not be a ref though. Okay, there we go. Maybe I should just rename cur, to be honest. This should be like, yeah, this definitely shouldn't be cur. This should be like, there is a term in the slides for this. Context. Yeah, that's what I should call it. Yeah, let's do that. There we go. That seems a little bit less awful. And now we can free up cur as well. So this can just be cur now. And that will make things a lot less awful to think about, I think. Yeah, there we go. That's a lot less awful. And then context also makes a lot more sense, I think. Well, it's not and T1 iter. Is there an instance where we... Okay, so this could just be a for each, honestly, I think. Right? Oh, wait, no. When do you update T2 scene? Down here. Okay, well, style-wise, I think I'll figure out whether I want to change this in the future. I guess I could probably update that pretty safely, huh? I don't know. I won't deal with it right now. Okay, so we have that. Okay, so while not seeing, so we have cur. This is the node star. Okay, so we want. Okay, so we want to cast this to register. So let's steal that. This should be cur reg. This should take cur. But this should actually just be a positive condition for this. For this instance, I think. Yeah, so we can do cur leaf and that. This doesn't exist anymore. This should just be cur, which is very pleasant. So we want cur reg and T2 reg. Same reg as cur reg. And so if it's the same, then we can't merge. This is a lot less unreadable once we get rid of all the gets. Okay, so this should be just T2 now, I think. Yeah, okay, much better. This is quite funny, actually. I miss C++ and alignment being something I used to worry about. Yeah, it's like, yeah, auto is honestly everyone's. Auto is like a giant maintainability boon. I quite like it. Here we're gonna need to use braces, I fear. For each leaf, we want to cast it to register. So we want okay, so this should be leaf reg or T2 leaf reg. So you can do that, and then so if that's a reg and cur reg. Oh wait, this should also be in that, right? Yeah, because cur is. Oh wait, no. Wait, do we care about cur reg? Yes, we need this to be a register. Yeah, okay. Because it shouldn't define the outputs. So this should take a big block around it. This goes in here. This should also go in here. So we want this and T2 leaf reg, or we want, Jesus Christ, what am I doing here? Cur leaf, this is, wait, what the fuck am I doing here? Okay, wait. Lock in. So we have cur reg, and that's leaf. Wait. What the hell am I doing? So what is this condition here? I definitely have this written down somewhere on the side. Okay, so we want no use in the range. So if this is a use, so we want cur leaf. Okay, so this only matters for this. Yeah, okay. So we should... Oh god. This is not going to plan. Cur leaf reg equals... Okay, this needs brace. So we want to do this sort of thing. Cur leaf. Oh no. That's shared. Oh no. What the fuck am I doing? Okay. This is going great. Okay, let's. Okay, lock in. So we want cur leaf get here instead. Please don't be ugly. It's ugly. Oh no. Beer shed the dreaded switch. Yeah. That would definitely not help here. Oh my god, this is terrible. Okay, I need comments here, or else I think I'm actually gonna blow up if I don't do comments here. Okay, so skip if, or cannot merge if cur is a cur uses if cur is a use of T2, that seems correct, I think. One go to or no go to? Yeah. Also, I don't think this many is that bad. The problem is just like the wrapping logic. The go to itself is definitely not the culprit. Fuck. So we have that seems fine. So if cur is a use of T2, yeah, okay. So cur leaf reg, ignoring this ugly line of code that I wrote here. This incredibly ugly line. So if T2 is the same reg as cur leaf reg, then we cannot merge. Yeah, okay, that makes sense. So then this one should be, this should be cannot merge if cur defines reg used by T2. Yeah. So that's the, I guess, like the inverse case, sort of. So we have to do this. Oh my god, what is happening here? Ah, okay. Okay, let's deal with this. Like what am I what am I doing here? Look at this line of code. What am I writing? What am I writing here? That's a new one. Okay, this deserves a mention in the Discord. Yeah, I'm throwing this here. What the hell am I doing? if T2 leaf reg and T2 leaf reg. What the hell? I know what happened is I didn't finish the if statement, but still, that is quite an incredible line of code written. Holy hell. Okay. Okay, let's try this again. So what am I doing here? So we want to look at the leaves. If it's a register and that is the same as we want cur reg or we want T2 leaf reg. So this is same reg as cur reg. If that's the case, then we cannot merge. Do you have the compiler rule yet? I have a compiler internship, which is a step in the right direction, but I enjoy streaming, so I'm not going to count that as I guess a compiler rule for the target of the stream, at least. Okay, this seems correct, I think. With a local trading firm in Chicago. yeah, they've basically given me the summer to just mess around with their GCC toolchain and see if I can make anything run better. It should be a good time. Still in university? Yes. Okay, so then this is the other cannot merge case, just if it has a memory instruction and that also has a memory instruction. Yeah, okay. So then this, we need T2, or T2 reg, same reg as cur reg. Yeah, okay. So we should probably just like put this at the top here actually. My friend come from the UK to Chicago and he enjoyed it. Yeah, that seems reasonable. It's a big city, lots to explore. I still want to visit New York. I think New York would be interesting. How do I want to learn compilers if I want to start over? I think the book Crafting Interpreters and the book, yeah, Crafting Interpreters is a good place to start if you're not familiar with like programming languages, period. There's like a Writing a C compiler book that is also good. Yeah, it's called Writing a C Compiler by Nora Sandler. Those two are the books I would start with. Personally, I would start with Crafting Interpreters if not familiar with programming languages theory. Do you use NeoVim? Yes. Okay, this seems reasonable. This merge stuff is going to be a mess. Yeah, this does not bring me joy. So what's the break condition here actually? I don't think this has a break condition. This doesn't look like it has a break condition. Hope you enjoy your internship. Thank you. Ended up sticking to my full time. Yeah, I guess that makes sense. It'd be nice if I could return full time, but if not, it's not the end of the deal. End of the deal. End of the world. Yeah, at worst, it gives me a chance to like pivot towards, I guess, jobs that are compiler related, which is still very valuable to me. Okay, let's make this a for loop instead, actually. So we do this, t2 iter not equals. This is going to be a really, really messy for loop, actually. So we want t2 scene equals true. Oh, that's a triple equals. What am I? Whoops. Let's see what. So this, we want that to. So this, so we want. So not T2 scene and T2 iter not equals we want context end. Yeah, we want this to be the rest of this. Take care, Ogre. Thanks for showing up. Take it easy. Have a good one. What's good, Gerbier? Good to see ya. Today's stream's a little later than usual, so it's all good times. Okay, so we want to just break if this is end of context as well. That's one past the element, so that means we're out of stuff in the context. Yeah, I think that I've just been forgetting about for some reason. That might also be the cause of one of my seg faults. Oh wait, no, we already checked for that. Yeah, if the use doesn't exist here, then that, yeah, we can't find it to begin with, so that's fine. This is really cursed, but... and then we want... Wait, no, this won't work. Right? Yeah, because we need to do this really gross thing in here. Yeah, okay. Yeah, let's just keep it a while loop, actually. That seems fair enough. So let's do that. Okay, so that's fine, that's fine, that's fine. Okay. Oh boy. Alright, so this is... Okay, let's de-nest a little bit actually. Let's actually invert this condition so that we can make this less ugly. So if it's not seen, then continue. Yeah, there we go. Now this is all on the same nesting level. And then we can get rid of that. There we go. That seems a little bit less ugly. Okay, so this we should merge. What the hell is this? So if it's seen, then T2 iter should be the right one. So we don't need to increment this again, I think. What am I doing there? Right, because we're already incrementing. Yeah, we're already incrementing. So this scene. So then they're currently the same register. And curreg is from the whatever the hell that is. So this should be. Okay, so let's make this cur. This should just be T2 iter, we want to get like this. Okay. So that makes sense. Yeah, so we can do that. And then we can static cast these. And this should just be T2 reg, I think. Yes, that's fine. Or is that out of... We already do this. What am I doing? Okay, so we can do that. We want cur reg. And this is... So that has to be a register. And then this should be just cur, I think. Yeah, okay. That looks a lot less ugly. So let's make that a new line. So we consume, this is like the actual merge, and then we need to, whatever the hell this is. I don't know what is happening here. So we want to erase the original pretty much. Yeah, this makes sense. that. What's wrong here? So that's a vector, that's a vector. Should be shared. We should actually just use that, I think. Do we get T1 leaves up here at all? No, we don't. Okay. Maybe I could do that once here even. Yeah, we do this twice. So we can just put this here. Yeah, so we do that. Okay. Do I need to ref this at all? No, okay. So we can do this. So we want to get rid of T2 shared. And is this in the for loop? Oh, this is in the for loop. Wait. Can we like do an enumerate then? Wait, we could actually make this an iterator. So want T2 iter, or wait, we already used T2 iter, right? Yeah, we do, okay. Okay, let's rename this to cur iter actually. Okay, that actually does make a lot more sense. Wish you the best of luck on your journey. Thank you. Appreciate the support. Okay, let's rewrite this. So so T2 iter equals. Actually, this is safe. We can definitely put this in here. Right, and let's not. This is not litter, this is just iter. Yeah, so we can do this actually. And then this should be iter and then arrow get. So we can do the same thing as above pretty much. So we can do that. Yeah, this is fine. Yeah, this iterates through them the same as it did before. So you can go here. This is T2 iter, I think. We can just do that. Or wait, no. So T2 iter is T1 in T1 leaves. So what's wrong here? Oh, we want this. Or we want to deref the iter. There we go. Okay. That's what I missed. So this, now we just insert everything. This is all cleanup stuff. What is cur? Yeah, cur reg is fine, I think. Does this want to be cur actually? This should be cur. Here we need to update reg to string, so we want, oh no. Maybe we can just do that. So let's do a quick dynamic cast real quick. All right, where's the uses list? Here it is. All right, we need to cast it to reg actually. Cur leaf reg, cast cur. Wait, what the? Wait, something was wrong up here, I swear. Ah, T2 leaf. Right. So we want this, get. Yeah, that looks more correct. Just by the name. But this also means something is wrong here. What am I missing? Oh, that has to be a register. Yeah, so we can do that. Yeah, okay. This code will just be a little bit clunky looking. Okay, so then this should, so we have cur leaf reg. This should be how do we handle this above here? Yeah, so we should like, let me just check this. Wait, where am I? This is not the right place. Okay, here is where we want to be. So get the reg. If not cur leaf reg, then we want to continue. Yeah, then we don't need to care about that leaf. Otherwise, we need to update the uses of this leaf. So we want uses, cur leaf reg, get name. There we go. This assert doesn't really do anything. That's fine. Yeah, okay, that's fine. Then we can push back to 1. That's good. And then this should be cur, I think, right? Or cur is a node star, so we want cur iter, or we want to deref cur iter. Yeah, okay. So let's rebuild, pray everything works. Let's see if it works. I hope it works. Yeah. I just hope it works. Okay, that's an MIR. Okay, well, it doesn't crash anymore. That's good. It doesn't merge though, which is not so good. Okay, well, that's at least forward progress, I think. Oh, that crashes though. Oh no. Okay. Let's give it another different test. Yeah, debugging this will definitely take a while. I'm not excited to do this for a while, but it is what it is. Let's give it call chain. Let's give mentor edge. It looks like it does something here, actually. Yeah, it definitely does something to the code. I'm not sure if it's good or not, but it looks like at least something is being merged. Right? Or am I tripping? No, I'm tripping. I'm definitely tripping. Nothing is changing here. The functions are being printed in reverse order. That's something I did not count on, actually. Because it's reversing everything, I think, is the problem. Okay, so we're gonna need to change the way we append real quick. We might need like one more buffer on this. Yeah, okay, let's do that real quick. Okay, actually, better idea. Let's move this out of here altogether. So we can take that. Let's put it here. There we go. So now this should at least vomit things out in the correct order. Yeah. Okay, this order is correct now. It sucks we're not merging anything, but it is what it is. Yeah, I've been streaming for a bit. I should probably call the stream here. We made a lot of good progress though. Let's do this. Rename print node visitor plus start debugging / rewriting merge trees. Yeah. Close quote. Okay. I think that's pretty solid work. Thank you all so much. Yeah, I'm calling the stream here. Thank you all so much for showing up to today's stream. If you're new here and still here, make sure you like the stream and sub to my channel. It really helps out a lot with the algorithm. While you're down there, if you haven't already, you should also join the Discord. Everyone's really chill. It's a great place to hang out. And yeah, you also can get pinged when I go live. It's way better than YouTube's system. Yeah, aside from that, my LinkedIn and GitHub are in the description as well. You should add me there to stay up to date with what I'm doing. Yeah, I'm a little bit hungry. I might make some ramen. Take care, y'all. Take it easy, and have a wonderful rest of your day wherever you are.